Hi everyone, welcome back to part 2 of this week's session, looking at repeated measures analyses using mixed models. So where we left off was looking at a two-way fully repeated measures design and the output, which suggests that there were two main effects, highly significant main effects or significant main effects, and a significant interaction. And we noted that that interaction was at one level consistent with the hypothesis that there would be an interaction between alcohol and task difficulty, but we also noted that the specific prediction that alcohol would affect task performance only for difficult tasks actually requires something a little bit further. It requires us to analyse the effect of alcohol at each level of task difficulty. So we therefore need to conduct simple main effects analyses of alcohol at different levels of task in order to test that. Okay. So let's just go back to that analysis that we just ran. Okay, this is what we just did. So now I'm just going to go down to simple effects. Okay, now again, as I stressed last time in the context of between participants ANOVA, it's really helpful when we're thinking about simple effects to have in your minds a main or sort of focal independent variable that you're interested in the effect of, and then think about the other IV or IVs as moderators, as things that that effect depends on. So in this case, we're interested in the effect of alcohol, so the simple effects variable, at different levels of, in other words, moderated by task difficulty. Okay. So now that I've added those simple effects options, we get the simple main effects output. So I'm just going to zoom in on that back in the slides. Okay, these are the estimated marginal means, by the way, so I'll just show you how to get those. Just go back to the example under estimated marginal means. If we check that, we get our breakdown of means for the main effect of alcohol, the main effect of task, and the interaction, the breakdown of alcohol by task. Okay. Okay, so that's those means. Now, these are the results of the simple main effects analyses. So we can see that the simple main effect of alcohol is not significant in the easy task condition. So this is the effect of alcohol in the easy task condition, nowhere near significant, but it is significant in the hard task condition. Okay, and just in terms of interpreting that, we can look at the means. All right, so is it consistent with the prediction that performance would be worse under the alcohol condition? Well, here is the mean for the hard tasks in the control condition. Okay, and the hard tasks in the alcohol condition. Now we can see that yes, indeed, performance is lower than it is in the control condition where participants completed the tasks sober. Okay, so all in all, this does look to be consistent with the researchers' prediction. Okay, it's helpful also again with interactions to graph it, and this is a graph that you can produce in the mixed model output, or sorry, the mixed model window in Jamovi. Okay, so again we can see here the slope is the effect of alcohol condition versus control, broken down by easy and hard task difficulty. Okay, so a fairly flat line indicating no effect for easy tasks, and a bit more of a slope indicating an effect for in the hard task condition. Okay, now let's think about other sorts of two-way designs that might involve repeated measures aspects, specifically mixed designs in which we're combining repeated measures variables with between participants independent variables. So again, let's go back to that first research question. Does students' alcohol consumption change over the course of a term? Okay, now let's make that hypothesis a little bit more nuanced. Let's extend it a little bit. So we've still got the same basic prediction that alcohol consumption will be lower later in a term compared to early and midway through a term, as we saw in an earlier example. But now the research is suggesting that maybe this won't be the case for members of sports clubs who maybe have more organised socials, which helps to sustain a particular level of alcohol consumption over the course of a term. At least that's what the researcher suggests. Now what this is suggesting is that there are two independent variables. Okay, we've got time, okay, as we saw in the previous examples, which is repeated measures. But now we've got a second independent variable, which is between participants. Is the participant a member of a sports club or not? And we're suggesting that there will be an interaction between these two IVs, such that the effect of IV1, the effect of time, will be different for sports people and non-sports people, okay, or sports club members and non-sports club members. In other words, an interaction effect. Okay, again, just representing that schematically can help. Here is alcohol consumption, or expected alcohol consumption at times 1, 2, and 3 for sports club members and non-members. So this is the sort of the decreasing trend that we saw earlier. Now the research is predicting that that's only going to happen for non-sports club members. High consumption tailing off over the course of the term. Whereas for sports club members, they're predicting that that level of alcohol consumption is going to be a bit more stable across term. All right. So in this setup for this mixed design, again, our option is a two-way mixed model analysis. So again, that tests three effects: the main effects of each independent variable, each of the two independent variables, and the interaction between them. Okay. Let's see what that looks like. So let's go back to Jamovi. Okay. So these are our data, okay, as we looked at before. So I'm just going to go to analyses and mixed model. I'm going to specify, again, just following exactly the same as the example earlier. Score is our dependent variable. Time is our first factor. But now also we have sports club member as a factor as well. So I'm going to pop that over as a factor. Participant, yet again, is our cluster variable for which we want random intercepts. Okay. Now, because we're specifying an interaction, I'm going to ask for the simple main effect of time broken down by, moderated by, sports club membership. And I'm also going to ask for the estimated marginal means, so we get a flavour of the actual pattern descriptively. Okay, there's our output. Now, I just want to stress it's also possible, because we have three levels of time, we could also look at the simple polynomial trends. So the trends of time broken down by sports club membership. Okay. So in this box here, this is now testing the linear trend over time for sports club members, and this is for non-sports club members. Okay. Or we can look at the difference coding, so the comparison of time 3 with times 1 and 2 combined, and now also broken down by sports club membership. Okay, so it's possible to dive even deeper into your simple main effects analyses, or sorry, your simple effects analyses, rather than just the overall effect. Okay, so let's just have a look at that, some of the key aspects of that output. Okay, this is again is our overall ANOVA table. So we've got significant main effects of time and of sports club membership. So sports club membership does seem to predict alcohol consumption, collapse across time points. And time, there does seem to be an effect over time of alcohol consumption, regardless of sports club membership, or collapsed across sports club membership. But the crucial thing for the hypothesis was this interaction, and that is not significant. So on the face of it, it doesn't look like the data support that particular hypothesis, that the effect of time would be different, or the trend over time would be different for sports club versus non-sports club members. Okay, these are the simple main effects of time. So this is the trend over time for sports club members and non-sports club members. Again, highly significant. And this is again a graph of those trends over time. The key thing here is that it illustrates why that the interaction isn't significant, because there is clearly some differences between sports club and non-sports club members at each time point, at least at times 2 and 3, the overall trend over time is very similar for both groups. Okay. So let's make our design even more complex. So what if we have even more than 2 independent variables? What happens if we have a third independent variable? All right. Well, let's go back to our sort of intermediate research question, the one focusing on whether alcohol consumption affects performance on hand-eye coordination tasks. All right. So now the hypothesis contains that same sort of key element of alcohol and task difficulty, but now there's an extra variable added in too. So the researchers now interested in testing whether alcohol consumption reduces performance on hand-eye coordination tasks, but only for difficult tasks and not for easy tasks. But in turn now, that this would be especially so amongst people who don't play sports involving hand-eye coordination. The logic being that people who regularly play sports that involve hand-eye coordination will be more resilient to the effects of alcohol on hand-eye coordination tasks because they're just a little bit better practiced at them. Okay. So now we have the same 2 independent variables as we did in the earlier example, alcohol consumption and task difficulty, both of which are repeated measures. But now we've also got a third independent variable. We're coding for whether the participant is a sports person versus not, and that's between participants. So here we have a 3-way mixed design. Remember, the 3-way refers to the number of IVs. And specifically, we're interested in testing whether the effect of that first IV, alcohol, depends on the second IV, task difficulty, but now in turn only at specific levels of this third IV of whether they are a sports person or not. And specifically, the key thing here to test this hypothesis is the 3-way interaction. That's what tests this level of contingency. Okay. The effect of IV1 depends on IV2, but only in turn at specific levels of IV3. Okay, again, schematically, that really helps to sort of visualize what we're suggesting here. So this is the effect of alcohol for easy tasks. And again, what we're suggesting is that, well, we're not really going to see any effect of alcohol here because the tasks themselves are easy. You won't see a drop off because the tasks are easy. But now for hard tasks, we'll see that effect of alcohol for hard tasks, and that will be particularly pronounced, that drop off, for non-sports people compared to sports people. Now with this design, our analysis options are a 3-way mixed model. Okay, so again, just like a between participants 3-way analysis of variance, we will get 7 different effects. We'll get the 3 main effects of each of the independent variables collapsed across the others. We will get the 3 possible 2-way interactions between each of the IVs, so alcohol by task, alcohol by sports person, and task difficulty by sports person. And finally, the 3-way interaction between all 3 of the independent variables. Okay, let's have a look at that in action. Back to Jamovi. This is our analysis. What I'm going to do here is actually just duplicate this rather than starting from scratch. So this is exactly the same as we saw before. We had alcohol and task as factors, scores our dependent variable. Now what I'm going to do is just add in sports club membership as our third independent variable. Okay. So now updating the analyses. And just one final thing here is that I want to look at the simple effects of alcohol, not just broken down by task, but also broken down in turn by whether they are a sports person or not. Okay. That's our output and our estimated marginal means. So back to the key aspect of that. Here's the main ANOVA table. So what we can see is, again, as we saw in the earlier example, significant main effects of alcohol and of task difficulty and the interaction between them is again significant, that two-way interaction between alcohol and task difficulty, as we saw earlier. But in turn, that three-way interaction is not significant. So what that suggests is this alcohol by task interaction we saw earlier, in turn, does not depend, or it does not vary depending on whether participant is a sports person or not. Okay. Turning now to the simple main effects analysis. So this is the effect, this is the simple effect of alcohol, control versus alcohol, broken down by each combination of sports person and task difficulty. Okay. So what we can see here is that the effect of alcohol is non-significant in 3 out of the 4 combinations, but it is significant, it's only significant in the hard task condition for people who don't play sports. Now, on the face of it, that looks to be sort of in line with what the researchers were predicting, but we have to view that in the knowledge that the three-way interaction was not significant. So although the effect of alcohol is significant here in this combination, we shouldn't interpret this as being different from these 3 other effects of alcohol. Okay, this is significant and these 3 aren't, but we can't conclude that those effects are therefore different from this effect. Okay, so what can we conclude more generally from that analysis? Well, firstly, alcohol consumption did reduce performance on hand-eye coordination tasks. Okay, performance was lower in the alcohol condition than in the control condition, and that seemed to be the case only for difficult tasks but not for easy tasks. So that's tested by the two-way interaction between alcohol and task, and in turn by those simple main effects of alcohol at different levels of task, and by looking at the descriptive statistics to confirm the direction of that effect. Now, the three-way interaction was non-significant, so that suggests that this two-way interaction in turn did not depend on whether participants played sports. Okay, so although that simple main effect of alcohol was significant in the hard task condition amongst non-sports playing participants, this effect was actually not significantly different from the effect in the other combinations. Okay, and that's what's tested by the three-way interaction, which was non-significant. Okay, that's it for this week on repeated measures designed using mixed models. Next time round, we'll have 2 mini sessions, in the first of which I will talk about effect sizes, so zoom in on effect sizes as a topic, and then the second mini session I will start to reintroduce regression as a means for analysing data in which our independent variables might be continuous rather than categorical. Okay, thanks very much in the meantime, and yeah, take care and see you next time.